Hello everyone and welcome to topic 5 convolutional neural network. These are type of network that currently we use for image processing and computer vision for different purposes and application. So far in this lecture we have discussed fully connected layer and you saw cascading of hidden layers in a linear operation plus some nonlinearity. However, when we have a structured data, using and applying fully connected layer is not a good idea. In this video, I'm going to introduce you CNN and we will review some application of Convolutional neural network, for short CNN, are a powerful family of neural networks that are inspired by mammalian visual cortex. This visual cortex contains a complex arrangement of cells which are sensitive to a small subregional visual field called receptive field. These cells act as a local filter over the input space and can exploit a strong spatial local correlation in natural images. As depicted in this figure, after we see an object, our retina passes this signal to LGN unit of our brain. And afterward, the signal is in ventral visual stream. Here, it has a different stages. At the first stage, we learn simple visual form of features such as edge and corner. And in V2 and V4, we learn the intermediate visual feature such as a group of the feature. And then in AIT and PIT, after 100 milliseconds, we know a high-level abstraction of the of the object. CNN architecture works like this. Like they are a stacking of multiple layers which they extract the features. In the beginning, at a low level layer, they extract local feature and high level layer extract and learn more global pattern. In another word, a CNN is a list of layers that transform the input data into output or class prediction. Work since 2012, and after AlexNet won the prize of the ImageNet large scale visual recognition challenge, are very popular in many fields such as computer vision, and we use them for the different purposes such as object detection, object classification, and also localization, as well as semantic segmentation. But the application of the CNN are not limited to computer vision. CNN also are widely used and applied in other domains such as natural language processing, audio, and also time series data as well. Here, the basic idea is they can extract the spatial features, and based on that, they can make the optimal prediction. It contains a different building block and component, and we are going to learn about this component in this topic. Computer vision is one of the fields that has been rapidly advancing to deep learning. Deep learning computer vision is also helping autonomous vehicles and robots figure out their surrounding, or more precisely what they see. We have different algorithms for image classification, object recognition, and detection, which at the core of all of these algorithms are CNN. Here, the system learns to drive in a traffic, in a rainy weather, in foggy weather, or even in winter, in local road, and therefore it needs really a set of the very high accurate algorithm. As we mentioned earlier, semantic segmentation is one of important application and use case of in a self-driving car, where here we are going to review pyramid sense parsing network as an example. Here the network takes the feature extracted by very deep convolutional neural network, namely ResNet 101, and they use this feature map and pass it to the pyramid parsing module, which they proposed by Gio et al. And in order to harvest different subregion of representation. Then they use the upsampling, convolution, and concatenating all of these features. And at the end, the result is semantic segmentation. As you can see here, the algorithm is very accurate and detected all the pedestrian and also like a detail of the input images and video very well. Another important application for autonomous driving car is road segmentation. Therefore, we have also many different algorithms for road segmentation. As you can see here is one example. CNN also shown a great job in medical image analysis and especially for personalized medicine. One example here is radiologist. As you can see, here is the hospital deploy AI tool for detection of COVID-19 from chest scan. In this example, deep learning algorithm used for the diagnosis, triage, and monitor coronavirus cases from lung images. And more importantly, this algorithm can predict who will need a ventilator. Well, this software actually is very helpful during the pandemic and this situation because they can assist the doctor for diagnosis process. As depicted in this figure, using 3D scan from single coronavirus patient, the radiologist algorithm can quantify the amount of recovery with a corona score. Moreover, this software is also able to do segmentation and measure the amount of the abnormality as well. Another use case of CNN is in pathology or computational pathology images. Here, the task is to, for example, instant semantic segmentation, where we would like to know what type of cells do we have in current macroscopic data, and also how many of these cells do we have, and how big or small is the size of this cell. And doing this using the convolutional neural network, you can see we can achieve really good results compared to the grand truth data. Image colorization is also another interesting application of CNN in computer vision. Here, the network takes the grayscale image as an input, and the task here is to solve the problem of hallucinating a plausible color version of the photo. Now, we need to classify or predict three different values for each pixel from top and then colorize images in a meaningful way. So far, CNN shown promising results in image recognition, but another key use of this technology is in speech recognition. For example, employed to say Amazon Alexa or texting with voice recognition. Here, at the most basic level, speech recognition converts sound wave to individual letters and ultimately sentences. Then these sentences transform using, for example, fast Fourier transformation to the specific windows in the form of a spectrogram. And the purpose is to actually reduce the dimensionality of the univariate sound data in a way that enables a specific letter to be predicted. Here, these windows, actually spectrogram windows, are the input for the convolutional neural network. And in this case, we actually train the neural network in order to classify emotion. Let's look at one CNN architecture. In the beginning, we have the input layer, which takes the input data, such as audio, text, or image. In this case, we can see one colorful images. Therefore, we have three input channel, and the size of images is 224 in 224. The images is from ImageNet dataset, and next is convolutional layer. which convolutional layer extract feature map from the input data. And here we have like a 64, for example, feature map. Like our convolutional layer also followed by a ReLU activation function in this case for the nonlinearity. And then afterwards, we have the red block or pooling, which is the max pooling. Here, pooling actually used to reduce the dimensionality of feature map and also filter the meaningful features. Then in continue, we have again convolution and pooling, and then we have the fully connected layer followed by a ReLU activation function. Well, here the fully connected layer connects feature map element to the output neuron, and at the end we have the classifier or softmax, which converts output values to probability score. Here the task is to classify images from ImageNet, therefore we have 1,000 class.